So from here, I want you to see, can you see the alphabet in red? A, B, C, D, E, and F. Yes or no? Can you all see? I can't see. I'm partial colorblind. Red and green, I'm done. Okay, that's why I never become a mechanical engineer. Okay, I cannot become electrical engineer also. Okay, I can't tell what color is what. Okay, so don't drive in front of me. Okay. Then so to activate A, you have to press alpha A. Get that? Yes or no?
Yeah.
Good. Then after that, you press close bracket. We're halfway there. Okay. Then we key in the next term. So the numbers are easy. 49.151 power of minus 3. I don't know whether we need to put a times or not. Did I put a times? Anyone to remember? I did not. Okay, let's risk it then. Holy shit. Exponential function bracket minus 17.682. And then again, alpha A. Have you done that?
Yes.
And then close your bracket. Then next, we are going to find equal. Can you see, besides solve, you have an equal sign, yes or no? Alpha equal, and then you equal to 0. Okay, now there is a possibility that they got no solution. Okay, that's why I'm taking the risk. I did not try on my calculator. Okay, so you type in everything already, yes or no? Very good. So the next thing is we want to solve this equation. Now, this is not like a computer. Okay, this is really slow. Okay, so now you press Shift. Can you all see the word solve? The color shift is in yellow, the solve is it yellow or no?
Yes.
Yeah, I can't tell. So you press Shift, solve the first time, and they ask you, oh, okay. Okay. And if you're going to solve for A, do that step again, Shift, stop. Is that answer already?
Yeah.
Holy shit! Okay, so you what? Yeah. I thought it did not work, yeah? Are we okay, yes or no? Are we good or no? You got it, yes or no? Really straightforward. I will post a video on it, don't worry. If you don't get it, I'll post it. That's why it's important to use the FX991. Okay, so be clear. This is so useful. Okay, I use this at least once a week. Okay, sometimes they have you check an exam question. Yes or no? Right? Okay, really good stuff. Right. So the answer, I thought it would take a long time. Bloody hell. It was so quick. I'm so embarrassed. So what we have come up with, right? That we know is when it reached to 0, right? When it reached to 0, okay, when this thing reached to 0, we know that this is, you all get 21.429, yes or no? You all get that? Close, approximately. Right. So you got that. Okay. Do you all want to learn how to solve this using Excel? Yes or no? Okay, I will now show you on Excel. I think these are good skills to learn, okay? So how to use this on Excel? I know it's Excel, okay? So Excel-wise, it's also not difficult. So you go to Excel, okay? Can you see the screen? Right, so now we are into we are in Excel and in Excel now, right? So T is the variable. Okay, so this is 1 for now. This is our time. Okay, so you need our. Can I ask you a personal question? Do you all like programming? You all like programming? I ask you all to embrace programming. I hate programming to the core, I'll tell you that. But it really makes my life easier. Okay, so when you have an education at McMaster, don't come in like nitrogen and leave the engine as a nitrogen gas. You understand what I mean? Is nitrogen combustible? No, it's not. Okay. After combustion, nitrogen will leave the exhaust pipe as what? Nitrogen, but slightly warmer. I don't want you to be slightly warmer when you come in from high school and leaving McMaster. I want you to become a freaking genius. Are we clear? So embrace programming. It does help. Trust me. I'm still learning. Okay, I am. Okay, right. So now we key in this function over there. Okay, so it's equal to 199.151 e to the power minus 3 times. Yeah, he said he's good in programming. Freaking equal sign forgot to put. And then exponential bracket, okay, minus 4.364, and then you times by t. Okay, so this is your first value. And then your second set of values, right, is equal to minus 40, equal minus 49.151 e to the power minus 3. I wonder e to the power minus 3 will work or not. Times by exponential function, close bracket again. So y'all can see what I'm entering, right? It's really straightforward. It's nothing rocket science. 0.682 times by what? Time. Okay. And you put OK. Okay. So there you go. 1 on the left-hand side, right? And then the results, okay, is equal to this plus this. Okay. We're programming it already. Okay. So now focus on Excel. Okay. I want you to go into data. Got it. Okay. Right. You click data. Then you click what if. Okay. Then after what if, you click go seek. Okay. So the set value is the results that you have compute. You want these results to be equal to 0. And by changing the time function, and we go. What do you mean it does not work, you cheeky sort? Now do it again. You click this, and then you press to value 0, because the results you want it to be equal to what? 0. And then you come to here and you press. So this is very embarrassing. It's 1.292. If I put it as 20, what was the answer? Let's say if I put a 15, okay? Oh, it's a, so based on, this is really embarrassing. As I said, I was not ready for this. So if I if I put this to like 0, okay? So if I put it to 0, it's equal to 0.15, right? Means your solution is correct, or your boundary conditions are implement. Okay, so we want that value to equal to 0 by changing this value. The answer is 1.263. Okay, but our calculator gives us an answer of what? 21.429. In the exam, are you going to use a computer or a calculator? I will mark you based on your what? Calculator. Are we clear? Okay. All right, the answer should be 1.2 something something. Okay. Made in Japan. Right. Okay. So now that is for that. And I hope you guys will be fine with it. Okay. Right. So the next thing that I'm going to introduce you. Okay. I'll see, do I need to do another example? Hold on. Okay, I'll do another example. Okay, on the same system, right? So what happened now? So I'm going to do another example. Okay. Again, we have a mass that's equal to 9.072 kilogram, and then the C is equal to 200 Newton second per meter, the damping coefficient. Now we would like to change K, the spring stiffness, to be 1250 Newton per meter. So this is what real life is all about, okay? You can either change the spring stiffness or you can change the what? Damper. Which do you prefer? Anyone? Will you prefer to change the spring stiffness or the damper? Anyone? Why? No, you go for the cheaper option. Yes or no? Don't be so focused on engineering. Sometimes you have to think about money. Okay? I know you are very keen, so am I. Boundary condition is still the same. Time is equal to 0. X is equal to 0.15 meters. And time is equal to 0. X dot is also equal to 0 meters per second. So the boundary condition is the same. The only thing that changes is the 1250. Okay. So very quickly to recap, the first thing they have to do, we have to check the C squared and what? 4 MK magnitude. Okay. So we know the C squared over here is equal to 200 squared. This is equal to 40,000. Done. Now the 4 MK changes. So you have 4. Mass is still the same. And now the spring stiffness is 1250. Okay. So this will be equal to 4 times by 9.072 times by 1250. Now will be equal to 45. All right. 360. So for this case, we have a situation where C squared is less than 4 MK, right? So with this, we go back to your formula sheet. You look at this like, okay, C squared is less than 4 MK. We have a condition of underdamping. Okay, we have a condition of underdamping. So for the condition of underdamping, we have X, it's a function of time. You have, what is the general? E minus alpha t, C1 cos omega t, plus by C2 sine omega t. And we know that omega is equal to 4mk minus by C squared divided by 2m. Okay. So now we are going to find out what is our alpha. I'm going to copy the whole example and go to the next page. So you will not
I will not make you guys confused. Okay, copy. Go to the next page. How I wish I can teach this in 3 hours straight lecture. Okay, but I can't. Right. So the first thing we are going to calculate is we need alpha. So alpha is equal to C over 2m. So this will be equal to 200 divided by 2, 9.072. Okay. So 200. So it's equal to 1111.023. Right? And then we have to find what is our omega. So omega over here, okay, will be equal to omega d. The d signifies natural frequency for a damped system. Okay, that is what omega d is all about. And then this will be equal to 4mk. Okay, 4mk minus c squared divided by 2m. Okay, so 4mk, we have computed our 4mk, so this is equal to 45,360 minus by 40,000 divided by 2, and the mass is 9.072. Okay, so 45,360 minus by 40, 123, square root divided by 2 divided by 9.072 is equal to 4.035 radians per second. I'm going to stop here. I will see you guys on Thursday. Friday, we are going to have 2 hours of lecture again. Okay. Yes. 1 hour, 30 minutes. Okay.
I understand everything. It's this one. How did they know that it's gonna follow this representation? Like how did they know?
Because
it's
you
gonna
plot it out, it slowly decays.
Oh, so they knew it was like exponential. Thank you.
I was wondering, can you explain the process for the calculation steps again? Because when I did it, I got an
Okay.
I got an error. So.
Do you have time after this? Let me stop here first. Let me pick up first.
Okay.
Okay.
Guys, question. So you know how these general equations are going to be on the formula sheet? What about the alpha, beta, and the
Yeah, they will be.
Okay, thank you.
Yes. Go on.
Did you